All right, good people, here we are. We've done 3 of the 4 tasks. Now we're back to task number 1. And task number 1 was going to be kind of the link to the binomial theorem. And it goes back to doing a little bit of algebra. So people that did task number 1, they were charged with doing the algebra that we're going to be using here when we do the binomial theorem. Here's what they found. They found that if you multiply x plus 1 times x plus 1, let me try to use my other pen, by the way. If we are multiplying that times that, then our answer here, if you distribute, right? Now you can distribute different ways. You can do this and distribute one term at a time. You can do the box method. But however you multiply, once you simplify, you get this answer. Boom. Now, what happens when I multiply, I guess I should say, when I multiply by another x plus 1? So if I have x plus 1 times x plus 1 times x plus 1, by the way, all of this would equal x plus 1 cubed, right? This would be x plus 1 squared. But what happens when I multiply by that? Well, that means I have to multiply this answer by another x plus 1, which again, you can use the box method, you can do distribution, whatever. But what these folks found was that the answer was, and my pen here, x to the third plus okay. Trying to get my pen to work here. There you go. 3x to the second plus 3x to the first plus 1. That was the answer. So they sat there and they did this for us so that we didn't have to do it. So now, what happens when we do x plus 1 to the fourth power? Well, that means I have to multiply all of these. And for that would take forever. Well, not forever. I shouldn't say that. But it would definitely take us time. But people that did task number 1, they did it for us. And this is the answer that they got. X to the fourth plus 4x to the third plus 6x to the second plus 4x to the first plus 1. But if you look very carefully, the coefficients that are present in every power of x are the same numbers that we got when we did Pascal's triangle. They're the same numbers that we got when we did the combinations. They're the same numbers that we got when we did the coin flipping. So what is this telling us? What we're creating is something, a shortcut, that's called the binomial theorem. And the binomial theorem says that if you ever have a binomial, this is what a binomial looks like, and you take it to the nth power, there's a pattern with the answer that we get. And what you're looking at right now is one of the patterns that comes out of that. Remember, I'm looking at the coefficients, 1, 3, 3, 1. Hey, that's the third row of Pascal's triangle. If you look at your task sheet where you're taking these notes, that's what that is. 1, 4, 6, 4, 1. That's another row. And then over here, 1, 2, 1. Hey, that's another row. So the shortcut is related to these numbers that are in Pascal's triangle, the numbers that are on the calculator with the combinations. We can accelerate our work and not have to multiply all of these by hand. There's a shortcut here. And this is the purpose of what we're doing. So, task 1 was kind of the baby steps that are going to lead us. Tasks 2, 3, and 4 were showing us ways that we can create shortcuts to get to where we want. And on the next video, we're going to put them together and and we're going to find out what is this binomial theorem business and how is it going to help us move things quickly. That's what the next video is about.